I
Yes.
fail to understand how our completely unplanned and random economy is going to manage to accommodate this. It
I
just isn't going to happen.
No, and that's the disappointing factor is when you think, oh, if we all just came together, it's so utopian. And you see just
Yeah.
trying to get something small done state by state by state, and province by province here as well.
Yeah.
It becomes enormously difficult to think how is this all going to come together?
Well, I've had presentations, Andrew, where I've presented in front of Americans, and I say, the United States has done the most of any nation in combating climate change. And everybody sort of goes, oh. And then I explain, you basically had a wholesale transition away from burning coal towards burning natural gas.
Yeah.
And the effect of that, of course, is yes, you're burning carbon, but you're also burning hydrogen when you're burning natural gas. And the fact is, you have about half the emissions that you would have burning coal. And they all pat themselves on the back and say, aren't we brilliant? Aren't we wonderful? And then I say, of course, you would have made the transition if natural gas produced 5 times as much greenhouse gas.
Yeah.
And they all go, how dare you say such a thing? It was just cheaper. I
Yeah.
mean, there was no carbon imperative that was applied. It was just natural gas is much cheaper because of fracking for oil. Therefore, we've got the natural gas. Therefore, we might as well use it. And all of these conspiracy theorists that talk about how there was a plot to get rid of coal or whatever else,
Yeah.
man, all you did was you moved the coal mining jobs to the oil fields,
Yes.
in Texas and in the middle of the United States. There was no plot to disenfranchise the American worker. It's just cheaper to do it that way.
Yes. And hopefully we'll get to that stage as well, where you'll take that technical skilled worker and just move them over to, once again, very technical jobs that will be high paying
Yep.
and
Yep.
whatnot. And we'll
Yep.
need them
And I,
on
and I,
scale.
and I'm hopeful, Andrew, you're going to see the same thing in China, where it would be nice to have a transition away from primary extraction, where they don't really have enough workers to go out and dig coal out of the ground anymore,
Yeah.
towards technical people that are working on the enrichment of uranium and thorium and the building of reactors to basically utilize those fuels and replace the coal-fired power plant. But we'll see. We'll see where the technology pushes us.
And then and just kind of wrapping up lithium, and we can look at, I know you've got some favorites, but I'll kind of preface this with big news that's relevant. Exxon announcing, hey, we're going to get into the lithium game. And we're looking at DLE, we're looking at
Yes,
technologies, we're looking at brines, we're
absolutely.
open to it. Very cool
Absolutely.
announcement. What's your take? What's your take on that?
But DLE is not, for me, wasn't the most exciting technology that was out there. And for good reason. It's expensive to use. In its current incarnation, the biggest issue with DLE is you have to keep lithium brines in contact with the material that extracts the lithium
Okay.
for probably the better part of or in excess of an hour. Now, if you think about the fact that a cubic meter of brine, really good brine, only contains kilograms
Of
of lithium, and a crummy brine might contain less than a gram in that ton of material. You start to kind of look at that and go, holding that next to this material for an hour is not much bang for the buck, and I'm going to need an awful lot of those cubic meters to produce any viable amount of lithium. That's the issue. It's
okay.
the cost of the plant. So when you look at some of these projects, be they in the oil field in the United States or in Alberta or wherever else, what you're seeing is a decent operating cost. Operating costs all in that are probably $7,000 or $8,000 a ton. That includes amortization and all of the rest of
Okay.
it. It's not
Yep.
so bad. I mean, even in our depressed market for lithium right now, which by the way is only cyclically and seasonally depressed. This is not a long-term situation that we're in. But regardless of that, you see that as being viable. The problem is the capital cost of the plant, where a lithium project in Argentina might cost $400 million or $500 million to produce a given quantity. You're seeing $1.5 to $2 billion costs for DLE.
Yes.
So if there were technologies out there that could drive that cost down, and I think there are, DLE looks far more attractive. But even at present, if we're going to have the demand that we're slated to have for lithium batteries, then we're going to need DLE, because the number of really good hard rock projects that can produce, the number of really good brines in a desert somewhere where we can evaporate away the water and concentrate the lithium, that's a limited number of projects.
Yes.
The number of projects with lousy brine, 50 to 100 milligram per liter lithium as opposed to 1,000 milligram per liter lithium in Chile, those projects are almost innumerable. So it'll turn into a case of, do you have the money and do you have the technology, as opposed to, do you have the lithium at all?
Yes.
And for the market, that's not a bad thing. If the price needs to sit long term in sort of the $15,000 range, well, we're almost at $15,000 right now, and we think we're getting a big break, because not that long ago, lithium was $80,000 a ton. So, I think I mentioned to you before, Andrew, if I had told, if I had told the companies in 2009 that we're making lithium, that we were going to have $15,000 chemical prices per ton, they'd have looked at me and said, listen, you've been wandering around in the sun for too long. Sit down. We'll put a cold cloth on your head until you get better. Nobody would have believed it. I mean, prices back then were $4,000 or $5,000 a ton, and we thought, things were good.
Yeah.
So, seeing this sort of long-term pricing, it's going to incent additional production, and it's going to be more than enough to put projects into production over time.
So it's great, because I mean, you are well known for lithium. I mean, it's 2009 when no one was talking about it. You've done every conference under the sun, speaking about. Pretty much.
I try to be realistic about it, though, Andrew, because yes, there's absolutely a transition going on, but there are, what technology giveth, technology can taketh away. You saw, over the last while, CATL in China announcing sodium batteries.
Yes.
As a replacement for some of the low-end lithium iron phosphate batteries. And you've now got Northvolt today in Europe announcing that they are going to market a sodium battery. So the sodium batteries do not use lithium. They do not use graphite on the anode, but they use the same battery manufacturing lines. So there's no need to put in new battery manufacturing capacity. It's just a different chemical powder going on the cathode and a different carbon powder going on the anode. But everything else is similar.
See, that's I mean, for like CATL not to have to change any of their production line or minimal production line.
It's the defining characteristic. I mean, I get confronted with new battery technologies every week. And
yeah.
People going, well, what do you think? What do you think? What do you think? The first thing I usually look at is, does it have a critical material need? Is there some magic dust that you have to sprinkle in this battery to make it go? And typically the answer is yes. Well, if we're only making it in quantities of, 500 tons worldwide, and your prospective demand is 10 million tons, I'm afraid that's not going to work, not anytime soon. The next question comes down to manufacturability. If you need to change all the battery manufacturing equipment, all multi-hundreds of billions of dollars worth of plant that has gone in, best of luck, because that's not happening next Thursday either. And the last aspect is typically just down to the technology itself, which is it viable? Does it satisfy a need? The really interesting thing that they're researching now, Andrew, especially in China, is they're pushing towards calcium batteries.
Okay.
So calcium as an ion has a double charge. And that means that you get a lot more bang for every calcium ion compared to lithium, compared to sodium. So the advantage here is, if that comes to fruition, and it's still early days, but it's feasible. If that works, you probably have a battery that's about as energy dense as some of the best lithium batteries that we've seen, but without any critical material demand, because calcium is everywhere.
Everywhere.
I mean,
yes.
We're swimming in the stuff. So, that wouldn't, there's no lithium threshold to get over, and that would be interesting. We'll see. But again, that's new days. The sodium batteries are commercial. They are being put in vehicles. They are being used. The calcium batteries are still research projects.
And this is where it can get overwhelming, even for someone like me who loves this stuff, is trying to keep up with the technology that's advancing so fast, but also keeping in mind, people say this regarding Tesla or regarding any EV company, is it's one thing to have even a prototype that works. Next is, that was hard enough. Okay, you did it. Like, and people go, holy smokes, that's genius. You go, well, now it's more difficult. Now do a production line on it. Can you actually now
Oh
produce
yeah.
it? That people don't understand the complexity of that.
I tell people I used to do alchemy. I did. I ran an experiment one time that basically was basically using a heavy ion beam to started to transmute lead into gold.
Oh no way.
Now it
Okay.
was so the things that I tell people after that is you're not allowed to ask three things though. The first is how much did you make?
Yeah. Yeah.
Because it was atoms. The
Yeah.
second is how much was it worth? The answer is not very much because it was radioactive. And and the last question, how long did you have it for? Again, it was radioactive. It didn't last very long. But the point was we could do it.
You
It's
could do
just
it.
on a commercial scale.
And how much did it cost in power to make
Yeah,
it?
let's not go there. I mean,
Yes.
we'll say the accelerators and everything else were sunk cost, and we won't talk about those. But even then, it was
Yeah.
pretty expensive for atoms of gold. Yeah,
But that is actually fascinating because once again, it's can we? Oh, we can, but
yeah,
now it's
sure.
not an economic and also just obviously that's an extreme case of
Well,
it's
I'll
yeah.
I'll I'll refer back to something we mentioned earlier, Andrew. But here's a pro tip for people when you get all excited about nuclear fusion,
Yes.
and you see the next breathless announcement that they've made a plasma and they've contained it for 5 seconds. And if only we could do this for 5 years, then we would have a viable project, la, 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 la.
Yeah.
The question that you want to ask yourself is, are they giving you not just the confinement time, but the temperature?
Oh,
Because
yes.
the two are inversely related. The hotter you make the plasma, and you have to hit at least a certain threshold or you won't produce any reactions and therefore no energy. The hotter you make that plasma, the more difficult it is to contain.
Okay. Yeah.
So if you want to contain it for 15 seconds, you just make it cool. And I can contain it for 15 seconds and announce a new world record and get my grant application approved. But if you actually want to make electricity, you have to hit a certain threshold. And then they'll say, well, we made energy, but we only made energy for a microsecond because
Yes.
that was the length of time that we managed to hold the plasma together. But all we have to do is multiply that by, a factor of a billion and we're off to the races. And the
Uh,
answer to that is we've been working on this since the 1980s.
yeah.
So, to do both of
Well,
those at the same time is extremely difficult.
and it's one of those memes that we're just 10 years away.
Yeah.
We're just
We're perpetually 10 years
10
out.
years
Yeah.
away. Yes.
Yeah.
Okay, and let's just jump in here too, because once again, I mean, there's always politics involved in all of this stuff right now. But we see back in August 1st, China, China and US have a bit of
Oh, yeah.
a tiff right now. So they put
Yeah.
their restrictions on gallium and germanium, and basically these are like for infrareds, for chips as well, electric transistors, whatnot.
Yeah.
But so walk us through why that's so important, and also the pricing. I mean, holy smokes, what happened in those two
Well,
materials?
actually, Andrew, it's fun. I mean, okay, first, what is it? Nobody knows what gallium is. Nobody knows what germanium is. Germanium is used in specialty semiconductors, as is gallium. So both of them in the right chemical forms, like silicon, are a semiconductor. And that means I can switch them by applying voltage through the right constructed device, a transistor, and turn the electric flow in another direction on and off, which is basically the basis of modern electronics. Gallium in particular, I combine with arsenic, and I create a semiconductor called gallium arsenide, GAAS, capitalization all over the place. Looks like a modern company name. What you end up doing with gallium arsenide, though, is you've made a semiconductor where the electrons actually travel significantly faster than in silicon. And the reason that that's fun is because in one of these, in a modern cell phone, I can generate the signals that I'm interested in without any trouble at all using silicon, using what's called CMOS technology. I can generate the train of ones and zeros that I need to generate to communicate with the tower and with the wider network. The problem is my CMOS silicon is really limited in terms of the power it can put out. It's just not efficient. And so as a result, trying to amplify those signals and dump them through an antenna off to the tower, I need something to amplify those signals up and be able to properly transmit them to do it that fast for 5G communications and beyond, I need gallium arsenide. I need a power amplifier that's made of gallium arsenide. So my view, the Americans had the CHIPS Act and they had various concerns about China doing all manner of publicly stated espionage and whatever else. The reason they basically withheld advanced circuitry and advanced manufacturing equipment from China is they don't want the Chinese market dictating what the next generation of communication standards looks like. They want to do it.
Yeah.
Okay. So they say you can't have it because you're doing terrible things and you're, security risks and oh my goodness. But really, it comes down to economics. And the Chinese turned around and said, great, if we're not even going to be able to build the 5G systems, the base stations, and the handsets for our own market, you can't have them either. So what they basically did is constrained the availability of germanium and gallium. The weird thing was they left an opening. They basically said, we can issue export certificates to whatever country, to whatever company we want. So if you're an American company and you need gallium, apply for an export certificate and we'll see. And that was an open invitation to, how about we have a back channel negotiation about the availability of these certain integrated circuits and manufacturing technology and everything else. I suspect that there's been some accommodation made because, well, you're not seeing a big difference in the germanium and gallium prices domestically in China, which is not a surprise because there's no export restriction there.
Yeah.
You are seeing a price increase outside of China, but it's been relatively slow.
Okay.
In building. We're not seeing panic buying in the space. And that would suggest that there have been deals made and there have been licenses allowed and material is continuing to flow. I haven't looked at the volumes because I haven't had a client ask me to go digging into the Chinese custom system to take a look at germanium and gallium. And believe me, that's fun if you've never used the Chinese custom system before.
Yeah.
But no, so no one's asked, but I haven't looked at volumes. I've just looked at prices, and the prices are reasonable. I mean, there is an increase in pricing, but it's been a very steady, gradual increase, no big disruption.
And just to reiterate to people, I think it's 94% of all gallium is produced in China and 60% of germanium.
Oh yeah,
so that's
there are no gallium and germanium mines. There's byproducts from other processing. But China dominates the processing in both aluminum and in zinc, which is where these materials are originating.
Yes, and the cost of so even someone says, oh, well, why don't we just build a bunch once again in the U.S. or Canada? Permitting, nobody is excited, and the cost is enormous. So,
yes.
And then,
well, again, we process bauxite, we process materials, and we could eventually put circuits in to extract germanium and gallium. But the volumes we're going to get are fairly minimal compared to the amount that we need, and it's going to take years and years.
And that's also an announcement and a statement when they see, wait, you're saying you're not decoupling, but you're decoupling. That tension starts. Right. Yeah. So
yes, and again, we start to pull further apart from people and from other nations at a time when we need international cooperation to solve problems like climate change and the like.
Well, this has been an absolutely fascinating conversation as usual. Go to stormcrow.ca. You do publish reports that you do put out.
Anything that we can make public facing, we make public facing. Some of it's proprietary, obviously,
but we really appreciate your thoughts and your knowledge base here. And we look forward to catching up with you soon because there's always developments in this space. And it is this hope that we see a real blueprint moving forward that, and especially where I'm optimistic when I see like the Cameco and with Westinghouse, and I see this announcement from the U.S. and they're having both sides, but it's Democrats and Republicans seem to be like, hey, no, we're on board with this. If that message gets through and they start doing an active kind of promotion or announcements that, listen, we agree on this. And also Exxon saying, hey, we're an oil and gas company looking at all these things. That's a big message that people start to go, oh, we are going down this path together kind of thing.
Absolutely. And, and again, Andrew, technology doesn't stop. I mean, it giveth and it taketh away. So the critical materials needs will shift with technology changes. And who knows what we'll be talking about is essential in a year from now.
Well, let's that we haven't even talked to this whole promise of AI and the computer power that's going to take and the energy it'll take to feed that system.
No, that's a whole different demand set and set of critical materials needs moving forward too.
Well, excellent, John. I appreciate it so much. Have a great day, and we'll catch up with you soon.
Thanks, Andrew. Take care.